sign of this as AB to the left. Now, if and
Hello students, welcome to my YouTube channel VRacademy. We are studying digital electronics, and this is the topic of discussion today, that implementation of Boolean algebra by using Demultiplexer. We have already done it with multiplexer. We'll try to learn that how it is getting implemented with the help of Demultiplexer. So I'm just taking an example, and with the help of this example I'll be telling you how to implement it. So the question is, implement the given Boolean expression by using 1:8 demultiplexer, where I have shown that y is a function of ABC equals a bar b bar c bar plus a bar bc plus a b bar c bar plus abc bar plus abc. So once you have got this, what is the next step to be done? I'll tell you what stepwise we need to do. The first step is that you need to find out what are the mean terms that are present over here. Now, using the concept of 4 to 1, which I have said you many a times, I can say that which are the mean terms that are present. This is a bar b bar c bar, so you can write it as 0 0 0. This one is 0 1 1. This is 1 0 0. This one is 1 1 0, and this one is 1 1 1. Now 0 0 0 is nothing but 0, so we can say that this is M0. 0 1 1 is M3 plus this one is M4 plus M6 plus M7. So this is the first step that you will do. Whatever Boolean expression that is given to you, convert that into the mean term summation. Okay. Now, sometimes it might be a possibility that this question will be not in a standard form. So the first step in that case will be to convert the given Boolean expression into standard form. Now, once that will be converted to standard form, we'll be able to get the mean terms. Now, it is obvious that how I have written 0 0 0 as M0, 0 1 1 as M3. It's very simple. If you are using the code of 4 to 1, it will be done in a fraction of minutes. 0 0 0, that means we are using nothing, therefore I am writing M0. 0 1 1, that means I am not using 4, but I am using 2 and 1. So 2 plus 1 is going to be 3, that is why I have written M3. And using the same concept, I have got all the values of M4, M5, M6 and M7. Now once we have got this, we have to directly jump to which type of multiplexer is given in the question. So it is 1:8, so directly draw that one, 1:8. So this is your 1:8 DMUX, 1:8. We know that if it is 1:8 DMUX, we'll have only one data input. Definitely it will have how many outputs? 8 outputs, starting with Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. So these are the 8 outputs. If it has 8 outputs, depending on that formula, n equals to 2 to the power m, 8 equals to 2 to the power m, so m will come out to be 3. So the number of select line in this case will be 3. Okay. Now, what are the changes that you have to make in order to implement that Boolean expression? I will give you the explanation of that one also later on, but for the time being, you understand what exactly need to be done in this multiplexer so that it will be implying this Boolean expression. So the first thing is, what you will do, you will connect this D with a plus 5 volt VCC power supply. Okay, that means I am making it as logic 1. This is the first step. Okay, then the 3 select lines which are present, we will have the nomenclature of these select lines depending on the variable, and you should be always giving the MSB bit as the first variable, that is A, B, C. You cannot migrate it, you cannot write it as C, B, A or B, C, A. Any pattern is not acceptable. The only acceptable thing is that you have to write the MSB bit as the first variable, and the last variable should be least significant bit or the last select lines. Okay. Now once you are done with this, you have to find out what are the mean terms that are present in the given Boolean expression, and those outputs are connected with OR gate. Those outputs are connected with the OR gate. So mean term M0 is there, so output Y0 will be active and it will be going to a input of a OR gate. Similarly, M3 is there, so we'll have connection of M3 over here. We'll have M4, so Y4 will be used. Okay, then Y6 is there, so I'm using this one, that is M6 is there, so I'm using Y6. And the last one is M7, so I'm using Y7. and finally all of them, whichever mean terms that are present, the same numbering output should be connected to a OR gate, and this will represent your final function, that is y is a function of a comma b comma c. The other outputs, that is y1, y2 and y5, should be connected to ground, So this is how we are making, or we are implementing any given Boolean expression by using multiplexer. It's a simple concept. First of all, you need to draw the mux. Input data should be connected to 5 volt logic, 5 volt VCC, that is logic 1. 3 or what many number of select lines are there. The nomenclature of those select lines will be the variables that are present, and it should be in a pattern that MSB should be given as the first variable and the LSB should be given the last variable. After that, whichever mean terms are present, those outputs are activated and are connected to a OR gate to give the final output. Rest all the outputs which are not present, or rest all the outputs should be connected to the ground. So that is how we are implementing any Boolean expression by using DMUX. Now, the other thing that will be coming to your mind, this is the implementation part. The other thing that will be coming to your mind, that why I have done it like this. What is the reason? So for that, for examination perspective, you need to do up to this. You need not have to think about anything else. But if you have to understand that why it has been done like this, we'll think about the output of 1:8 mux. What is the output of 1:8 mux? It is y0 equals to S2 bar, S1 bar, S0 bar, D. Y1 is how much? S2 bar, S1 bar, S0 D. Y2 is S2 bar, S1, S0 bar D. Y3 is S2 bar, S1, S0 D. Y4 is S2, S1 bar, S0 bar D. Y5 is S2, S1 bar, S0 D. Y6 is S2, S1, S0 bar D. And Y7 is S2, S1, S0 D. Okay, so now let us compare these outputs with this DMUX, and you will be able to get the answer why it has been done like that. So Y0 value is S2 bar, S1 bar, S0 bar. But what I have done, I have replaced those select lines with the variable, that is A, B, C. So what will be the output in this case? It is A bar, B bar, C bar, D. Okay. And simultaneously, I have also made all the values of D equals to logic 1. That means anything multiplied with 1 will be like this. Okay. Now, what is this expression? This is nothing but your M0. Similarly, about this one, it is A bar, B bar, C, and D is equals to 1. So this is nothing but M1. Similarly, this is A bar, B, C bar, that is nothing but M2. This one is A bar, B, C, that is nothing but M3. And simultaneously, if you will go on, you will be finding out the last value will come out to be A, B, C, which is nothing but M7. Now, what we have done, this is what the output is now. If I am giving this data input as logic 1 and converting these select lines as A, B, C, we are getting M0, M1, M2, M3, up to M7 as the output. So we can say that this is nothing but M0, M0, M1, M2, M3, M4, M5, M6, and M7 as the output. Now, M0, M3, M4, M6, M7 are present and they are added. So they must be connected to a OR gate. So we have just connected them to OR gate, and that is why that will be coming as the output. So I think it is, all of you must have got it, that how to implement a Boolean expression by using 1:8 mux, DMUX, sorry. Now, a question for all of you is to design a full adder by using 1:8 DMUX. I want that all of you should be trying to solve this question by yourself. If you are finding out any doubt, you can comment me in the comment box and ask for the answer. I will, depending on the comments, I'll be giving you the answer of this one. But I want that you should be solving it and coming up with your answers in the comment box, that you have done it, and how you have done it, you can have the explanation in the comment box. Thank you for joining. We'll be going for the other videos in the next classes, next upcoming classes. If you have any suggestions, you can come up with that. Thank you for joining. We'll meet once again in the next video.